Hi guys, it's Dimitris, and in this today's short presentation we're going to watch a short tutorial on how to create a wipeout style hover vehicle in Unity 3D game engine. So, I understand that you know what a vehicle is, of course. So, what is wipeout? Wipeout is a pretty old game, but it was, very exciting back at the time, I have to say. Basically, you controlled a ship throughout a specially designed map. It worked like a hovercraft, so it bounced, onto the stage. And basically, it was a racing game, so you had other opponents and that. In this short tutorial, we're going to basically replicate the hover mechanism, and we're going to make the vehicle go forward, backwards, and turn left and right. So no more slides for the time being. Let's get to the demo. So I'm gonna open Unity. So first of all, we're going to show you the final result. So let's press play on the editor. Here you can see the vehicle that is basically hovering on top of the surface, and I can move it using the arrow keys. See, you can see I'm now turning. I'm now pressing the up key, the right, forward, and I can also go backwards. Okay. So let's create a new scene in order to replicate this. And we're going to create, first of all, a new plane, which will act as a small stage. Let's make it a bit big, 10 on the X, 10 on the Y, and 10 on the Z axis. Basically here it seems a bit black, so I'm going to create simple light, which is here on the directional light. Okay. And then we're going to create the vehicle. We're going to create a small 3D game object, a cube. So make the cube 3 on the Z axis or Z, whatever you prefer, and 2 on the X. And I'm also going to make it red, so it's, it seems a bit different than the white on the on the plane. So we're going to create the vehicle and to move the vehicle using physics forces. So I'm going to add a rigid body. I'm not gonna fiddle, with the properties around here, the mass, the drag, and angular drag. Basically, the only thing I am going to do is freeze rotation here. So basically, we want the vehicle to move, forward, left, and right, and we also want it to rotate on the y-axis. So we don't want it to rotate on the x and z axis, which is, we're going to freeze the rotation there. Okay, so basically we now have a twofold problem to solve here. So first, we want to create, the wipeout style, let's say, hovering mechanism, and then we want to create the mechanism, that the vehicle responds to the player input and moves left and right. So we're going to create a new C# script here. I'm gonna call it vehicle. On pressing enter again, Visual Studio will open. So we'll use it, to write our code. First, we'll need some public variables in order for the developer, to be able to ourselves for this, be able to set, the values of, first the hover value, so the hover height, which is the distance, of the plane, and the distance which the vehicle should be, first of all, and then we want to create a value so that when the vehicle drops a bit, we want to create a value that will designate the force, the value of the force that this will take in order to go upwards and then continue to fall again. So we're going to create a public float, let's say hover force. Let's say this is 20, and hover distance, let's say this is 2. Okay, and since our vehicle has a rigid body component, we want to get a reference to it, so we can use it throughout our script. So basically this can be private. We don't want this to be visible outside our class. So private rigid body, car rigid body. Okay. And on the awake method, we don't need the start right now, we can set car rigid body equals this dot get component. We can call the generic method, which will get a reference to the rigid body component. Okay. Okay, I prefer my brackets to be like this. Now, we are going to use the fixed update method to do physics. So basically, as a rule of thumb, you should always use fixed update, to add forces, fiddle with physics, because in the update, maybe you have a frame rate difference between, frames. So, you might see some anomalies there when you're doing development. To be on the safe side, just use fixed update, and apart from, some exceptions, you should be okay. So on the fixed update, now what we're going to do, basically our vehicle is here, gravity is applied onto it, and it falls, towards the ground. So basically, when we want to do when the vehicle is too close to the floor, which close is designated by the hover distance variable, we want to add a force, so the vehicle can go up. So it will have, basically this movement. Okay. In order to calculate the distance, we can use array cast technique. So basically, imagine array is thrown, from here towards the plane, the floor. If it is collided, it means that they are pretty close by. Okay. So in order to use arraycast, we're going first to create array equals new array. We're going to use this overload. So first parameter is the origin, from which point the array should start, which is the origin of our vehicle, and then the direction. So in the direction, if the vehicle is here, this direction is transform up, so this one should be minus transform up. Transform dot up. Okay. Then we're going to create array cast hit variable, which we'll use in the next statement. So if physics dot arraycast, we're using the static arraycast method on the physics object, and we will use this overload. Okay. Array, there are various overloads that you can use here, but this one is more appropriate for our problem. So the first one is the array, then it is the output variable hit, and then it's the max distance. So this will be the distance of the array, which won't equal to the hover distance variable. So if this is true, it means that our vehicle is pretty close to the ground, to the plane. Okay. Here, what we want to do is, apply a force, onto the vehicle. And for a smooth movement, it would be good if we applied a proportional force, and proportional, regarding the distance. So if the distance is here, then we would give a bigger force compared to, if the vehicle was in this distance. Okay. So how to find this proportional distance? So let's call it proportional distance, let's say, which basically would be the hover distance minus hit distance. Okay, so basically, the hover distance is the variable that we have set here. The hit distance is, distance between the vehicle and the plane, divided by, to make it proportional, divided by hover distance. Okay. Then I want to create a vector that will basically contain, the force that will be applied. Let's say force to apply, and basically, the force will be upwards. So on world space, upwards is vector 3 dot up, multiplied by, of course, the hover force. Okay. Multiplied, of course, the proportional distance variable. Okay. And how should we apply this method? This force, car rigid body, car rigid body, add force to apply. Okay. So let's go back to the editor. Uh, let's rename this to vehicle, for better organization. You should also, in complete projects, you should also create a scripts folder here and drag and drop the vehicle script over there, but for a tutorial it's not necessary. So basically, let's test that the rigid body works. So let's check the camera. The camera is orthographic. Orthographic is for 2D. Perspective is for 3D. Give it a little bit on the Y. Okay. So we are going to see now that it fell. Okay, so normal physics. But if we drag and drop here this one, we will see that probably will float onto the air, and yay, this works. Okay, so we have solved this first part of our problem, the vehicle floating, onto the surface. Now for the second part, first of all, we need to declare some variables. So we need a forward speed, which is gonna be, of course, float forward speed. Let's say this is 20, and turn speed, which will be just 1. Okay, and we also need 2 more private variables. We can omit the private keyword here, but nevertheless I like it. So we want to capture here forward input, and we'll capture here the turn input. Okay, so basically we are going to capture the value of the user pressing up, down, left, or right, or WASD on the update method, and then we are going to apply physics forces, with these variables to the fixed update method, because if you recall, we always apply physics on the fixed update method. So forward input, we will use the static method input.getAxis on the vertical, which means up, down, or WS, and turn input equals input get axis horizontal. Okay, and onto the fixed update method, we're going to apply forces again to the car. So here we used the add force method, but now we're going to use the add relative force method. Basically, the add force method takes a vector and it applies it, in the world space. Okay, but the relative force, this one, and the relative torque, to turn the object, basically apply these vectors, to the vehicle, to the object local space. So for the vehicle, we want, its local space to move forward, and we want it to rotate, throughout its local space. That's why we're going to use relative force and relative torque. So vector 3 here, if you recall, here is our vehicle. We want, when we want this vehicle to go forward, we want to move, this blue arrow here, which is the Z. So 0 on the X, 0 on the Y, and on the Z, forward input multiplied by forward speed. Forward speed, and car rigid body, add relative torque. So we're going to rotate on the Y-axis, so 0 to X, on the Y, turn input multiplied by turn speed, and Z on, and 0, sorry, on the Z-axis. And, well, I think we're done, so let's test it. Okay, so we can move the car, we can see it rotates, but, we can't move it, whereas while it sees, we see that it's moving, we can't, see any visible difference here, and that's why I have created a small prefab here called clouds. So basically, let me take them a bit higher, and we will see that, now it is moving. And, as all in racing games, we want the camera, to be behind the car. Basically, there are 2 ways to do that. First of all, we could create a script that basically is attached to the vehicle and gets a reference to the camera. It basically, does if the car turns, basically, does a smooth turning of the camera too, but this is too complicated for a tutorial now. So what I'm going to do is drag the camera behind our vehicle. So let's give it a bit here on the Y and rotate it a bit. Sorry, not on the Y, but on the X. And yay, we can see it working, and our car is running like crazy. That's all. Back to the slides. So if you want to practice more, some next steps, some next things you could do. First of all, the Unity Asset Store, has a cool asset, so nobody likes to move a red cube around, an area. So basically, check our asset store, find some assets, or you could create a map using the terrain objects on Unity. To make it fun, you could also use some motor sounds, some headlights, with the lighting objects that Unity has, some exhaust fumes, some flames, whatever. You can use the particles system in Unity, also known as Shuriken. And basically, it's always fun to shoot things. So you could also, let's say, throw missiles with physics, or basically, if you are doing laser shooting, which is more precise, you could also use some recast techniques and maybe some line render objects, to leave a trail as the laser leaves your aircraft. That's all. Till next time. I hope you write awesome games, and if you have any questions, feel free to contact me here. Thank you.